Hello, my name is Igor and I have a measuring tool review in this video. And this digital micrometer is sent to me by Banggood for a review. And it will be one of the main tools in my grip test which I'm preparing, and you will see it in the near future. Now, I already have a micrometer and I use it in earlier videos, but as some of you noticed, it is not really camera friendly. Now, before I open this box and analyzing this digital micrometer, I would like to talk about measuring tools a little bit. Now, if you are in a 3D printing hobby or business, you probably have, or you should have, a caliper. And it is not so precise like a micrometer, but it has several advantages. For example, most common versions can measure the distances between 0 and 150 millimeters or 6 inches in imperial versions. And we can measure the outer dimensions, inner dimensions. We have a dip meter. And some calipers have even this step meter. And even if these mechanical versions can have both scales, the metric and imperial, on the same product. Now let's talk about the micrometers. The main part of every micrometer is the screw with very precise thread. And this thread has the pitch of 0.5 millimeters on metric versions. The imperial versions is 1/40 of the inch. Now, this thread must be very precise, and the manufacturing is limited, so usually they are manufactured in very short distance. For example, this one here is between 0 and 25 millimeters, so if I want to measure 40 millimeters, I have a version which is between 25 and 50 millimeters. Another problem with the thread is that the backlash, it's very minimal, but because of that backlash we cannot have universal measuring tool. We have separate, for this is only for outer measuring, and the separate micrometers are for inner dimensions and for deep measurements. So as you can see, it is not that universal like the caliper, but it has more precision thanks to that precise thread. One also very important specification is that they have the ratchet or the torque limiter here. This prevents me to over tightening the dimensions, because we are talking now almost precision of the 1 micrometer. This one has the precision of 0.01 millimeter, but there are some versions, even mechanical, which has some additional vernier scale here, so they can really measure the precision of the 1 micrometer, and that's 0.001 millimeter. Imagine 1 millimeter divided into 1,000 parts. Okay, now let's see what's in the box. On the box outside I can see electronic digital micrometer from 0 to 25 millimeters or 0 to 1 inch, and the precision is 0.001 millimeters or 0.0001 inch. Well, I have here some operation instructions. In instructions I can see that the real accuracy is 0.002, so the reading is 0.001 millimeter, but the accuracy is 2 micrometers. This is the wrench for the calibration, and this is the micrometer. So this is the micrometer, and it doesn't came with the battery, so I have to place the battery myself. But as a backup, I can see we have the analog readings on it too. Wow, it is dead precision. I don't even have to use the wrench to calibrate the mechanical readings. It is on the spot. If it is not, then I have to use this wrench. There is a hole, and I can rotate this cylinder to get on the 0 position. The 0 should be aligned with this line, completely precise. So I can calibrate it myself. But this is not the reason why I asked for this micrometer, but the digital reading. only I have to insert the battery. This is LR44 battery. It's already working. So this is the matic version. This means one rotation will move the micrometer half millimeters, but this is only a backup reading. The main reason I asked for this caliper is this digital reading, and with this I can calibrate it myself. So I just place it to 0, press the 0 button, and it's zeroed. And I have a button I can switch to inches. Now the reading is in inches. Now let's test the accuracy. I have here milling parallels. I'm not sure if they are completely super precise on this dimension, but what I know for sure that these two surfaces are parallel with each other, so the repeatability can be checked with this micrometer. Now, a few things about this micrometer. It says the accuracy is 0.001 millimeter, but I wouldn't trust this completely. Theoretically, yes, but imagine, so this small precision is very sensitive. Even if I hold this micrometer in my hand for just 1 minute, the thermal dilatation will have effect to accuracy of this micrometer. Also measuring the object, if it is not on room temperature, if I hold it in my hand, it will expand, so the accuracy is a very sensitive thing. But for me, actually, 1/100th of the millimeter accuracy is far enough for me, and for me what is important, that camera can easily read this value here. Now actually one of the first tests you can do with your micrometer is to check the repeatability of the 0 position. So now it is zeroed, and I will move the position of the micrometer, and then go back and to see if I will get the 0 value again. Okay. Of course you have to use the ratchet and move it slowly, because if you can easily over tight it if you move on this position. Let me show you. Now it is 0 and I can tight it even 7 microns more. Now let's measure these milling parallels. 14.00. .001 millimeter, and that error is possible even manufacturing, or maybe if I hold it in my hand it will expand, so definitely this is quite precise micrometer. Let's check one more. These are 10 millimeters, I think, yes. Wow. I thought there is some error in the these parallels, but even they are precisely manufactured. These are 12 millimeters parallels. .002 millimeters. And now at the end, let's check again the 0 position. Great. It is very important to try to hold this plastic part, because if you hold here it will warm up a little bit, and that expansion will definitely have effect on this micrometer precision. You can buy separately stands for the micrometers, but like everything else, also there are some 3D printed versions and you can download them from the Thingiverse. And one last measurement is measuring the thickness of the hair. I know what are you thinking, but don't worry, I live with 4 females, so I will find the hair in almost any room. Probably it is not even visible on camera. .045 millimeters thickness of this hair. And the final conclusions, it was a really pleasant surprise that it really gives that accuracy of 0.002 millimeters mentioned in the specifications. I tested it not only in this video. And my favorite is that it also has that mechanical readings too, so in case if I run out of the battery, I can still use it without it. Of course, I don't have that precision anymore than that, but as a backup solution, it's great. Now, in 3D printing, do you need a micrometer? Probably in most cases you don't need this kind of precision. The only reason I can see you may want to have a micrometer in a 3D printing hobby is this ratchet here, a torque limiter, because with the caliper measuring the plastic you can have quite different values. It depends how you press that caliper to the plastic. And with the torque limiter you can always get constant values reading that. Of course, I try to give you some kind of oral review too. I also do a lot of metalworking, so there I really need this precision. But it depends on your needs, but I hope I could give you some useful information. And the second tool I will use in that creep test I mentioned earlier, it will be the torque wrench. But more about it in my next video, and I hope you will follow me to that video too. Until that, thank you for watching. Bye.